I've completed a measurement session on this fixture here, and I aligned my measure data to the CAD model using iterative alignment based on the location of the three tooling spheres. They're a little tough to see. I could zoom in right here a little bit and show you that there's some spheres in the model, in this rendered model. And what I'd like to show you, though, is how to take this alignment and set the weights on it based on these three spheres. I'll zoom out one more time here, and maybe I'll get rid of my rendering for just a second too. But here are the three spheres. I've got one on this left-hand side, one in the middle, and one on the right-hand side right here. And I'll go up to review features here a second. And here is the alignment that I went through, and show the details on it for just a second. It's an iterative alignment based on the three tooling spheres. And then I'll highlight these three tooling spheres and show you that in the model here. Notice that the spheres all solve for the y component. I'll just scroll down a little bit. Just know that the left-hand sphere is the one here at the top. But if I go to view them, notice they're all highlighted red. And all three of them had to solve for the y component here. Well, that makes sense. I have to have three to solve for that up-down component perfectly. So it solved for that. I'll right mouse key to go back in. But I've got some variation in the x and the z on each of these tooling spheres. Well, after I've done that alignment, my client has come back to me and said, you know, we'd like to take all of the variation and split it based on the location of the center sphere for left and right. And I'd like to take all of the variation for the fore-aft component, which is the z in this fixture here. They want to take all the variation and solve it between a line that's formed by these two spheres. Well, that's super easy to do when you set the weights on your iterative alignment. I'll right mouse key to go back into that. And since I've got my alignment out here right now, I'm just going to highlight that alignment. And I'm going to go to the Edit icon right here. So it brings up my iterative alignment dialog box here again. Now I will go and set the weights. And what the set weights does is it allows me to set or to dictate which components, the x, the y, or the z, is being held by the features. In this case, they're spheres. So I'm going to hold some of those locations based on those spheres. I'll say OK to that. And now notice this dialog box that comes up here. This is the Iterative Fit Values dialog box. I'm just going to move it out of the way just a little bit, just to show the three spheres that I've got. Here's the left, center, and right. Now, all three of them have to solve for up-down. That's the minimum I can use for the up-down fit. So I'm okay with that. The one component in this box says, yes, go ahead and fit for the up-down or the y component. Now, if my client's telling me that this middle sphere right here is only used for solving me in the cross-car component, well, I have to use it for the y anyway. But if it's only used for that cross-car component, I'll scroll down just a little bit, you can see that that is my x component. So I want the x component for the center to be a 1 or a yes. But I do not want that to solve me for the z component. I'll zoom up a little bit, get this thing out of the way. I don't want that center sphere to solve me for the z component. So I'm just going to deselect it there. Same for these two spheres here on the left and on the right. I have to use those to solve me for the y. But I don't want them to solve me for the cross-car component. So I'm going to deselect them in the x. Now I'm going to say OK. And it goes back out and it resolves for that alignment here in Review Features. Now if I highlight the three spheres here and look at them in Review Features, remember my client was saying that the middle or the center sphere, he wants that to solve for cross-car, which is the x component. Okay, well, setting those weights sends that right down to 0 deviation. And again, its y component is still 0 for the up-down. And okay, then the two left and the right spheres were used to solve for the z component, which is the fore-aft. Now notice I've got 0 deviation for those components in the spheres left and right. Well, that's exactly what I wanted. I wanted to set the weights or dictate which components, the x, the y, or the z, was being controlled by each of those spheres. So if you need to dictate the components, the x, the y, or the z, to have a control in for after, for up, down, or whatever direction, the setting the weights is the best way to do that in the iterative. And since I've had this in my model already, it was very easy to do by just highlighting the alignment and going to the edit and setting weights here. But if you didn't have an alignment on this part, you could do it under the alignment menu and then the iterative here, and that same dialog box shows up and you can set the weights here. One thing I do like to do, though, make a note of this, is that after I do these alignments with setting weights, I like to go back into the review features and just make sure by highlighting your alignment features that they truly are to the x, the y, and the z component with the deviation that you'd expect.